Number 2 is going to have us do that same problem with a different point. So we want to know, is point 22.3 on the circle? So I'm going to pause the video for a moment, or you can pause the video for a moment, and I'd like you to give that a try. Like, how can you do everything that we just did in here? Now, I get you won't be able to actually draw on the grid, but you could still sketch that out, right? You could sketch that out, and then really, it's all about the numbers. We don't really have to have the grid. The grid just helps us give that visualize. Let's see what you can do. All right, let's see if you got some things right here. The point we're now testing for is 22.3. So that means we go over 22 and up 3. So yeah, you can see that, yeah, that looks like it's pretty close. 22.3. So we're going to identify that point right there as 22.3. So we want to know, is that point on the circle? Well, what does that mean? That then means that from the center to that point has to be 17, because any radii of the circle is 17. So again, that's what we are testing for. Ooh, it's looking a little messy already, right? So here would be my hypotenuse. So in order for me to create the right triangle, I need to go down to 3 and over to 22, right? So now I have that right triangle again. So I'm wondering, is my hypotenuse 17? What is the height? And what is the length of those two legs? So let's set up what we know. We know we're going to find the difference. So we have this one right here. So we were at 10, right? Because this is our height, right? We're up here at 10, and we had to go all the way down to 3. So 10 minus 3, and then we know we're actually plugging this into the Pythagorean theorem, so that would be squared, plus then what is the distance right here? So we were at 6, but we ended up at 22. So 22 minus 6, and we know that that's going to be squared. And then we know that that needs to be equal to 17 squared, because if this is definitely a point on the circle, it has to be a distance of 17 for our hypotenuse. So 10 minus 3 is 7, so 7 squared, plus 22 minus 6 equals 16 squared, needs to equal 17 squared. So 7 squared is 49, plus 16 squared is 256. And from the problem up above, 17 squared is still 289. So let's add this together and see if it equals 289. 49 plus 256 equals 305. So in this case, it does not equal. So this is not a point on the circle. So how could you say what we did in general terms? Like if somebody said, how can you see if a point is on the circle? What would you tell them? What did we do? What kind of math was involved? So you might say something like, you might find the change in the horizontal and vertical points from the center to any point in question. And use Pythagorean theorem. .3, building an equation for a circle. So now that we kind of already did the math, what is that equation that's going to work every single time we want to test to see if a point is on the circle? And so this time they're just giving us, well, any point x, y, right? So we can put any numbers in there to see if it would be a point on the circle. So here is the x and y. Here is our center value. So here is a circle with center -3, 6 and a radius of 13 units. So we know that what we're looking for is all radii from the center to the edge will be 13 units. And again, we can sketch in those right triangles to test it. But let's build then that formula for any point. So let's draw in our hypotenuse. And we know that this has to be 13. How do we know that? Because that's what it tells us right here. The radius is 13 units. So we're not making that up. That's the given information about the circle. From center, -3, 6. So we know that this is an x value, right? And this is also a y value. Any ordered pair is written that way. So if I want to know if that is 13, I'm going to create that right triangle. Here's my distance, horizontal distance, the change, and here's my vertical distance change. That would be the right angle. So let's focus on the x values first, right? So my x value was -3, and it's now x. So if I wanted to write that in the equation, I would write -3 minus x. And then I know that has to be squared because I'm going to use Pythagorean theorem to see if indeed it does equal 13. And then I'm going to add that to, well, how big is the other leg? Well, in order for me to find this distance, I've got to take the 6 and I've got to minus the y value. And I'm going to square that. And you might say, well, what if I end up with a negative number in here, right? Well, remember, anytime I square something, any negative times a negative ends up being a positive number. And that's why this formula works, because even if this number is negative, when I square it, it ends up being positive. And then we know that this then has to be the radius squared. In this case, we know the radius is 13 squared. So this would be the formula for us to determine if any point on this circle right here, if it actually is on the point. So now they want us to use the point 9, 1. So we're not even going to focus on this diagram right now. We're going to show you that all I need is this formula right here. I need to know my center and I need to know my radius. So let's go ahead and plug in the numbers. So this is the x and this is the y value. So here we go. -3 minus x, which is 9, squared, plus 6 minus the y value, which is 1, squared, needs to equal 13 squared, because the radius is 13. So this is one of those examples where we're going to end up with a negative number in here. -3 minus 9 is -12 squared, plus 6 minus 1 is 5 squared, equals 13 squared. All right, so let's do the math. -12 times -12, so that negative times a negative is a positive. So 144 plus 5 squared is 25, needs to equal 13 squared. which is 169. Okay, so let's add it together. 144 plus 25 equals 169. So 169 does indeed equal 169. And so yes, that is a point on the circle. Okay, so this next step takes it to the what is an equation of a circle. So this we were given the center and we were given the radius. But what if we're not? Okay, any circle has a center and we're going to call that center point HK. I don't know why, but that's what we give it. Okay, so the x of the center value becomes h, and the k of the y of the coordinate of the center becomes k, and we're going to keep radius as r. So that makes sense. So now we need to write an equation that it would allow us to test any point, right? So just like here, I took that x value of my center and I wrote that first. So this is still that x value. So I would write h, right? And we know h has to minus the x value. So just like when we do proportions, as long as we're talking about the same number, we really can't mess that up. So this is x, even though this is an h. It's in the x position. It's that horizontal, right? So h minus x squared, okay, plus k minus y squared equals the radius squared. Now, that makes sense, right? Now, what though, some people, the formal formula is actually switching these two things around, okay? So instead of saying h minus x, the traditional formula is x minus h, or the opposite of h, plus y, and the opposite of k, squared equals r squared. Okay? Either one of these will give you the exact same answer. So this right here is the equation of a circle. And it will work for every single circle.